Okay, good morning, students. Today we start with the cloud computing. First of all, we have the introduction of cloud computing. What is cloud computing? Cloud computing is the on-demand availability of computer system resources, especially the data storage and computing power, without direct active management by the user. Large clouds often have the functions distributed over multiple locations, each location being a data center. So this is what about the cloud computing. Basically, what is cloud computing? It is on demand availability. First of all, I'm going to clear the one thing that cloud computing is, it is a combination of two words, cloud and computing. Computing means any function performed by us is called a computing. Suppose we are working on our laptop and we are interacting with some applications, it is called a computing. Or we are making a resume, it is also called a computing. Even if we are using the calculator and make some calculations, it is called a computing. So what it means, every type of computing that held in the cloud, all the activities that are related with the computing but that can be held on the cloud, it is called the cloud computing. And what is cloud? Cloud basically is a space, or you can say the services that are available at the server side, that are not available at the user side. For example, suppose you want to do any application. Suppose I just give you a program that make a program of addition of two numbers. So what will you require? First, you require the operating system. Second, you require a system software, that is C++, in which you are going to make a program. Third, you require a storage space, or you require a particular RAM which required by the C++. Execute your program and store your program on the space. These all are available in our laptop. But whenever we are not going to use the services of our laptop, and we are going to use the services that are not present on the laptop but that are present somewhere else, this technique is known as cloud computing. So what will be happened? We only required a username and a password. Suppose we have a username and a password of cloud computing. As we discussed in the previous lectures, number of companies who are giving the services of cloud computing. Suppose we are considering the example of Google Cloud. Google Cloud is there and we are making our username and password over there. Whenever you open the window of Google Cloud virtual machine and where you log in with your username and password, a screen is open where three type of services are available. The first is IaaS, that is infrastructure as a service. And in infrastructure, all the RAM, ROM, hard disk, these services are available. Second one is PaaS, that is platform as a service, where we have the number of different platforms that are available on your screen. Suppose you want to make any program that is compatible with the Android, then you go for that. And some, or you go for any program that is available on the Windows, then you go for the Windows. So what it means, in the case of PaaS, platform as a service, you have the different types of operating systems are there. And the last is SaaS, that is software as a service, in which number of softwares, for example MS Word is there, for example MS Paint is there, Corel Draw is there, other different type of softwares are there. You are eligible to work with any software. Now what is the difference? There is only one difference. Whenever we are using the cloud computing, we have infrastructure is there. Infrastructure, first what we are discussing in the infrastructure, the storage space and the RAM. We have the number of different softwares which required a minimum of 8 GB RAM. As in the case of Android, whenever you're working on the Android lab, minimum requirement of the RAM is 8 GB. That is not possible on the every system. But whenever you are using the Google Cloud, the lot of GB space is available for you. Second, it means all the platforms. It is not easy for us to install all the platforms on our laptop. So what will be happened? Just go for the cloud computing, which platform you required. Double click on it. Without installing that platform, you are able to work on the platform. Third one is SaaS, that is software as a service. Number of softwares are available over the market, but we have the limited softwares in our laptops or in our systems. Whenever you required a new software, what will you do? You install that software, then after you are using that software. But whenever you are using the cloud computing, no need of installing any software. The software is already installed by the server. You simply double click on the software and go for that. So what it means, each and everything that is available in the laptop, or that might be used by the users in future, that everything is available on the cloud computing. And the best part is we are not going to install any application, any platform, or there is no restriction of there is no restriction of infrastructure over there. So this is called cloud computing. This is all about the cloud computing. Okay, the next is the recent trends in the computing. Now we have the different trends that are working over the market in the computing, or you can say the different techniques from which, with the help of these techniques, we are making our computing. The first one is grid computing. Second, cluster computing. Third, distributed computing. Fourth, utility computing. And at the last, fifth is cloud computing. Now we are going to discuss one by one each and every computing technique. Let's start with the first one, that is the grid computing. A grid computing can be defined as a network of computers working together to perform a task that would rather be difficult for a single machine. All machines on the network work under the same protocol to act like a virtual supercomputer. The task that they work on many may include analyzing huge data sets or simulating situations which require high computing power. Computers on the network contribute resources like processing power and storage capacity to the network. Grid computing is a subset of the distributed computing, where a virtual supercomputer comprises of the machine on a network connected by some bus, mostly Ethernet or sometimes the internet. It can also be seen as a form of parallel computing, where instead of many CPUs cores on a single machine, it contains multiple cores spread across the various locations. The concept of grid computing isn't new, but it is not yet perfected, as there are no standard rules and protocols established and accepted by the people. So what is the nutshell of this? In the case of grid computing, we have the number of computer systems are there and they work together. They have the same protocols runs on the machines. Basically they are making the load balancing. What it means, if we have a problem or we have a query which have a big data set, then it is not easy for a single computer to make the analysis on that data set. So what we can happen in the grid computing, they can make the load balancing, they can divide the data set and give it to the different machines, because the same protocol can be executed on the different machines and they can work together. So it, if us any problem, it requires a huge computing power. We have a number of computer systems are there. Suppose in our grid computing network we have a 10 computers. So what will be happened? 10 computers means now the computing power is 10x. If we are using a single computer to operate that problem, we have the 1x power over there, or 1x storage space is there. But whenever we are in the grid computing and we have the 10 different systems, the power is 10 time multiply. So what it means, the computing power is 10x and the storage space is 10x. So that's why it is easy to compute a complex problem on this particular network. Clear? So working, a grid computing network mainly consists of three types of machines. Basically, in the case of grid computing, we have the three different types of machines are there, or you can say the three different type, the combination of three different type of machines, they make a grid computing. The first is control node. A computer, usually a server or a group of servers, which administrates the whole network and keeps the account of the resources in the network pool. So what it means, we have a network of 10 systems. We mark a single network as an administrator. If a single computer who is administrator and who controls all the activities of this network, and that particular computer is called a control node. Clear? Second, provider, the computer which contributes its resources in the network resource pool. A computer who gives its resources in a resource pool means a resource pool is a combination of all the resources that are available on the different computers and that are the part of that network. They are called the providers who gives their resources to the network. They are called providers. The third one is user, the computer that uses the resources on the network. And the third one is a users. A user is basically, you can say, a computer who uses the resources that are available on the network. It is called a user. So these are the three different kinds of the machines that are working together in a grid computing. Now, this is a simple example. Now look at here. This is a node. Look at your screens. Node, the operating system is the Kali Linux operating system is executed on there. So what it means, it is a basically a part of the Linux family. Now, this is a second node. The operating system window is working on this different node. Now come to the third node. The operating system is Ubuntu. It is a version of the Linux. Now, look at here. The OS Mac operating system is executed on this node. This is a simple node. No operating system is there. And Debian operating system is executed on this node. And these all the nodes, they are connected with each other, and the central node is called a control node. As we discussed in the previous slide, a control node is an administrative node which controls all the activities of the network. So what it means, it is a grid network. They have the different computer systems. They have the different operating systems running on that, but they can be controlled by the single computer, and that single computer is known as the control node. So this is the simple example of grid computing. This is all about the grid computing. Now second is cluster computing. Cluster computing is a collection of tightly or loosely connected computers that work together so that they can act as a single entity. Either they are tightly connected, means directly connected, or loosely connected, means indirectly connected, to make or to show a user as a single entity. The connected computers execute operations all together, thus creating the idea of the single system. The cluster are normally connected through the fast local area networks. Now, look at here. This is a simple diagram. We have the computer 1, computer 2, computer 3. They can be executed by the root node, who is responsible for the activities of these nodes, and the data is input to the particular node. And whenever a root node who is accepted the data, it can divide that data in between the different nodes. And they are the bidirectional arrows are there. Whenever a node who is making or who process that data, it can revert back to the root node, and root node give the result to the desired output. Now the cluster computing. Why is cluster computing important? The cluster computing gives a relatively inexpensive, unconventional to the large server or mainframe computer solutions. It resolves the demand for content critically and process service in a faster way. Many organizations and IT companies are implementing cluster computing to augment their scalability, availability, processing speed, and resource management at economic price. It ensures that computational power is always available. It provides a single general strategy for the implementation and applications of parallel high performance systems independent of certain hardware vendors and their product decisions. Now, The types of cluster computing. The first is high performance clusters. That is called the HP clusters. Are HP clusters use computer clusters and supercomputers to solve advanced computational problems. They are used to performing functions that need nodes to communicate as they perform their jobs. They are designed to take benefits the parallel processing power of the several nodes. Second, load balancing clusters. Incoming requests are distributed for resources among several nodes running similar programs or having the similar content. This prevents any single node from receiving a disappropriate amount of task. This type of distribution is generally used in a web hosting environment, means which can be balance the load in between the different nodes. They are called the load balancing clusters. The third is high availability, that are always available for the users. That is also called the HA cluster. HA clusters are designed to maintain redundant nodes that can act as a backup system in case any failure occurs. Whenever any failure is occur over there, we have the number of backup systems are there. They are act as the high availability clusters. Consistent computing services like business activities, complicated databases, customer services like e-websites, and network file distributions are provided. They are designed to give uninterrupted data availability to the customers. Basically, they provide the uninterrupted. Why the uninterrupted? Because backup systems are there. If any single system is going to be halt or that is failed due to some reasons, the backup systems are there and they can make the data available for the users at every time. So these are the different types of the cluster computings. Now, the next is the distributed computing. Distributed computing is a much broader technology that has been around for more than the 3 decades now. Simply stated, distributed computing is computing over distributed autonomous computers that communicate only over a network. Distributed computing systems are usually treated differently from parallel computing systems or shared memory systems, where multiple computers share a common memory pool that is used for the communication between the processors. So what it means, as the name implies, distributed computing. The number of systems, they are connected with each other, but they are distributed over the different locations. But they are the autonomous entities, but they work together in a network. Distributed memory systems use multiple computers to solve a common problem with computation distributed among the connected computers and using message passing to communicate between the nodes. For example, grid computing is form of distributed computing where the nodes may belong to the different administrative domains. Now, what will be happen in the case of distributed computers? There are the number of different machines. They are connected with each other and they can communicate with each other with the help of message passing. They can communicate with each other by sending the messages. Now this is the diagram of the distributed computing. Now look at here, this is the node number one. The processing node is there. It has their own processor and the local memory is available over there. Now the another node is there. They have its own processor, the own local memory is there. This is the communication channel. Communication channel means they can communicate with each other by sending the messages. With the help of message passing, they are communicate with each other. One thing that is different from the previous techniques is the number of systems that are the part of the distributed computing systems. They have their own memories, they have their own local memories, they have their own processors. They are the autonomous activities, means they are the different systems. We simply make the connection between these systems. So this is distributed computing. Distributed computing, a method of running program across several computers on a network, is becoming a popular way to meet the demand for the higher performance in both high performance scientific computing and more general purpose applications. There are many reasons to show the increasing accepting and adoption of distributed computing, such as performance. The availability of computers to connect, fault tolerance, and sharing of resources, etc. By connecting several machines together, more computation power, more memory, and input-output bandwidth can be assessed. Distributed computing can be implemented in a variety of ways. For example, group of workstations interconnected by an appropriate high-speed network may even provide the supercomputer level computational power. So this is all about the distributed computing. Distributed computing, I'm going to be repeat. It is a combination of different systems. They are the autonomous systems. Autonomous means they have their own processor. They have their own local memory over there. So what is the benefit of this? The benefit is this. Suppose whenever we have a problem or whenever we are going to compute something, we have the combination of 10 different systems. We can be easily make that system or start that problem with the system number one. Suppose we have a problem and we have a query. We are solving the 20% of the query on the system number one. Then this is same thing is available on the system number two. So we can start solving that query from the 21% on the other location. Suppose on the second system, we done it on the 50%. Then we are calling the person who is available on the location third, where the system third is available, and he started working from the 51st percentage. So what it means, automatically the computation power is more, the memory is more, input output bandwidth is also more, and the performance is high. Why the performance is high? Because at the same time 10 different systems, or you can say 10 different users who are available to work on the particular condition or to work on a particular problem. So this is the advantages of the distributed computing. Now the next is utility computing. Utility computing is the process of providing computing services through an on-demand pay-per-use billing method. Utility computing is a computing business model in which the provider owns, operates, and manages the computer infrastructure and resources, and the subscriber accesses it as and when required on a rental metered basis. Utility computing is one of the most popular IT service model, primarily because of the flexibility and economy it provides. This model is based on that used by conventional utilities such as the telephone services, electricity, and gas services. So what it means, they are the on demand or the billing system, like we have a billing system in our they give the example of electricity. The number of units used by us, we are going to pay for that units. So these process or these technique in the IT is known as the utility computing. The principle behind utility computing is simple. The consumer has access to a virtual unlimited supply of computing solutions over the internet or a virtual private network, which can be sourced and used whenever it is required. The backend infrastructure and the computing resources managed and delivery is governed by the provider. Utility computing solutions can include the virtual servers, virtual storage, virtual software, backup, and most IT solutions. Cloud computing, grid computing, and managed IT services are based on the concept of utility computing. So what it means, they all are based on utility computing. And the basic idea behind the utility computing is, if you want something, you go for it, and the which time or whenever you are using that particular service, you only have to pay for that service. This is all about the utility computing.